3 videos, and they're for Federal Highway. It's going to be a video on density and durability, smoothness, and then also one on long life pavements.
Okay.
So, yeah, so the questions that you saw, kind of a full battery that we've asked, gotten a lot of good responses from all that, but here in this late hour on Tuesday, we don't want to subject you to all that, but I do want to get a chance for you to talk about your expertise. Would the Bailey method apply to density and durability?
Sure, absolutely.
And smoothness as well? Or?
Yes, indirectly, because it applies to compactability of the mix, and compactability of the mix definitely plays a role in smoothness,
Okay.
along with a whole lot of other things.
And is it applicable also to long life pavement?
It is to better understand asphalt mixes to meet whatever kind of specification we're trying to meet,
Okay.
if that makes sense.
Yeah. Now, so where do you teach? You teach through university or?
I teach a class down at the Asphalt Institute in Lexington, Kentucky.
Okay.
Generally 1 or 2 classes per year, and have since 2004.
And people that come to take the class, are they contractors or agencies or who?
Primarily contractors, some consultants, some agencies. I've had, several.
Okay. Well, we'll get into it here. So the first actual question I'm going to ask you is the toughest. That's where I ask you to say and spell your name and to give me your title, please.
William J. Pine, William J. Pine. My title is the Quality Control Director of Asphalt Technology for Heritage Construction and Materials, based out of Indianapolis, Indiana.
Okay, very good. So talk to me a little bit, Bill, about the relationship between density and improved durability and performance.
There's a very direct relationship. The higher we go in density, the lower we go in permeability, which keeps water and air out of the pavement structure to prevent moisture damage from a stripping standpoint, to reduce oxidation of the binder that we've coated the aggregate with. From a stability standpoint, any mix is stronger to a point the higher density we achieve in place. So density impacts both basic characteristics that we look for in an asphalt mix. We look for stability and we look for durability. And a higher in-place density helps both aspects.
So how would you introduce or define the Bailey method?
It's simply a systematical way of looking at an aggregate blend, better understanding how aggregates pack together, not just from a gradation standpoint, because other properties of the aggregate influence a few tests that we run in the Bailey method. Shape of the aggregate's important, texture, or more specifically microtexture, strength of the aggregate's important, as well as shape of the particles. So type and amount of compactive effort plays a role there too. Are we using a 50 blow Marshall? Are we using 100 gyrations? Are we using a Texas gyratory compactor? That plays a role in how that aggregate gets oriented when we compact it in a lab mold. The same thing occurs in the field. Are we using vibratory breakdown rollers? Are we breaking down with a pneumatic roller? What type of compactive effort and how many passes are we making at a given point in time?
It sounds like that there is a strong association and or correlation with the Bailey method and its role in density and durability. Could you talk about that?
The Bailey method definitely helps you better understand for a given set of aggregates how to achieve, I'll call it an optimum packing point within a set of specifications that you're trying to meet. It's applicable to basically all of the types of mixes that we deal with: fine graded mixes, coarse graded mixes, SMA like we're talking about as well this week. And it does have some applicability to open graded mixes also.
Let me ask you this then. Are there any changes to pavement design or asphalt mixture design that would make achieving consistent density easier for paving contractors?
Absolutely. Probably the one thing that I don't hear discussed near often enough is lift thickness and what role it plays in being able to orient particles in the field when we compact a mix. There's plenty of reports out there to provide guidance on minimum lift thickness, but with funding issues that virtually all agencies are faced with today, it's common for us to place mixes at or even below what's recommended as a minimum thickness. As an example, when we have a target air void to meet relative to lab compaction on a mix, it may be 3 to 5% and the target's 4. And that's the point we're trying to achieve on average during production. The same can be said in terms of lift thickness. There's a minimum lift thickness, and if you go beyond that point, you're really going to struggle to orient particles, achieve density. If you go above that thickness, you'll also struggle with density because you won't get the particles on the bottom part of the mat oriented like they need to be. But there's a spot in the middle that's right for that type and size of mix. Is it fine graded? Is it coarse graded? Is it a 9.5 millimeter nominal size? Is it a 25 millimeter nominal size? We target the center of an air void spec as an example, or asphalt content or what have you, but we're typically leaning against one of the goalposts when it comes to lift thickness in the field. So something that agencies could do very quickly, I think, to improve compactability in the field, and with that get a higher density, lower permeability mix, is to simply increase thickness. Before anyone screams and says, but we don't have the money to do that, the next thing to look at is, do we really need a 19 millimeter mix for this? Can we use a 12.5? Because they're limited on thickness from a funding standpoint. I think it's a large misconception in our industry, as well as within the agencies, that nominal size of a mix drives strength of a mix. Not always true, especially if there's a difference in what you can achieve in density of those two mixes. So an alternative to not increasing lift thickness, but having the lift thickness that's better suited for that mix, is simply using a smaller nominal size.
That's good. Anything else about density and durability that you wanted to bring out?
I think intelligent compaction is probably going to help things a lot, along with warm mix and what we've learned over the last few years, because as well as looking at temperature variations in the mat. Anything we can do to not just increase density, but increase uniformity of the density, I think will also play a very important role in improving long-term durability of our mixes.
That's good. Moving on to smoothness now. What's the role of mix design in smoothness?
Relative to lift to thickness that we're placing, if a contractor has a choice, wide enough acceptable gradation bands, and they can meet all of the specification requirements in terms of VMA, optimum asphalt content, film thickness if you have it, any kind of strength measurement or cracking measurement, what have you. If you have the choice of being fine graded or coarse graded with the materials you have and the specifications you have, leaning towards a fine graded mix can definitely help with compactability in the field, because we're typically at that minimum in terms of what's acceptable lift thickness for that nominal size. So if in turn a specification or our materials force us towards a coarse graded version of that nominal size of mix that we're trying to place at that minimum acceptable thickness, durability can suffer. Permeability definitely is going to be higher. There's plenty of information to show permeability of fine graded versus coarse graded mixes at the same density, same nominal size. But it also plays a role in smoothness, because the harder we have to fight to get density, the more we have to work to compact it, the higher chance we stand in actually increasing roughness of the mat. The pavement that we place with the paver is as smooth as it's going to be. We don't roll smoothness into a mix when we compact it. we're trying to not roll roughness into it by the way we compact that mix. And part of it has to do with lift thickness and mix type that we choose to use or specifications drive us towards.
That's good. That's a great answer. I haven't heard anybody say it like that about the fact that you don't roll smooth the sand. You have to just avoid rolling roughness in. That's very well said. There's many more questions here, but let me ask you this. Anything else that you wanted to bring out about smoothness?
Probably the number one thing that we deal with today that I believe impacts smoothness that's achievable is what we're laying on. I started my career with the Illinois Department of Transportation in 1985 and left there about 20 years ago, but have seen in that span of time roads rehabilitated multiple times, the same section of road. And I think it's easy for all of us, industry and agencies alike, to forget about what's below the portion that we're working on and how it's changing over time, and that's what we're trying to compact a mix against. So that definitely plays a role in the resistance or lack thereof of that pavement structure as we're compacting and moving a roller down the road, and I believe induces roughness into the mix.
That's good. Did you hear that? Mm-hmm.
I mean, I think it's out of the voice range, so we'd probably remove that.
Okay. All right, so moving on then to long life pavements. And of course I know it's also called perpetual pavements. Federal Highway is branding it, or brands it long life pavements, so we'll, for the sake of this project, we'll refer to it as that. And I know that really that's kind of I guess talk about the mix design, because I understand that, you know, you're doing things to it's not the subgrade, is it, but it's the lower level of the asphalt to try to prevent that bottom up failure, that bottom up cracking.
Mm-hmm.
So the philosophy on how those first layers are placed have changed with the long life pavement approach. So is that an accurate statement?
Yeah.
Okay. So I guess my question then is, Bill, talk about how pavement design is different for long life pavement, and then, you know, what does that bring to the end product?
Number one, if you're talking about a long life pavement or a perpetual pavement, it's a newly constructed or completely reconstructed pavement. So it starts with the subgrade, then onto the subbase, and then onto construction of whatever multiple layers of asphalt we have. Question one really is, what kind of loads do we expect that pavement to carry over a period of time? There has to be at least a minimum thickness that's going to allow it to have enough fatigue resistance over time to bend but not break. Several have went down the path of using a rich bottom base layer that improves fatigue resistance at the bottom of the mat, and then building up with other asphalt mixes, more common asphalt mixes above that point, maybe with a superior surface course that will allow it, as long as that pavement structure as a whole is sufficient to resist the loads over its life, or what we see it to carry as best we can predict it today for what it's going to be 20 or 25 or 30 years from now. If it can resist fatigue resistance, then simply we can manage that pavement from the top down. Typically, our pavements fail from the bottom up, either due to lack of sufficient structure and they simply bend too much and they break, no different than a coat hanger. But there's also the possibility of moisture damage down there as well. That rich bottom base helps resist moisture damage. being at a higher asphalt content, higher density, lower in-place permeability. But we still have to have the either a group of mixes above that are at an acceptable level of permeability or even lower to keep moisture from getting into that pavement structure overall. And in this case, if you're dealing with a rich bottom base getting trapped on top of it.
That's good. So, talk about stone matrix asphalt's role in long life pavements.
SMA offers the best of both worlds in terms of those two main properties we look for in any asphalt mix: some degree of stability, some degree of durability. With pretty much all of our dense graded mixes, we lean one direction or the other. If it's a highly traveled route, especially with heavy truck traffic, we lean towards the stability side. If it's a low volume route, we lean towards the durability side. SMA offers both: stability from the coarse aggregate interlock and the quality of the aggregates that are used in that mix, but being placed with a higher asphalt film thickness around it and at a higher density, lower permeability, it offers improved durability characteristics as well. I think our challenge in the U.S. with SMA is having enough aggregates, quality aggregates, to be able to use with the specifications that are out there today. Interesting at this conference that there are people discussing the use of local aggregates, which I think is a good thing. I think we can make a good SMA mix with a lot of our local aggregates, especially if we can get shape, a more cubical shape produced of those materials.
That's good. Anything else on long life pavements that you wanted to bring up?
I don't think so. Other than, I guess, let me rethink that. Because we're constantly looking for ways to make our product, as far as asphalt mix, greener, or being asked by the owner to make it greener. More recycled materials in it, both aggregate and binder, waste products of some kind. As we move down the road and use higher recycled content mixes in long life pavements, industry and agencies together have work to do to understand how to properly use rejuvenators, as an example, to bring back characteristics to an aged asphalt that's being added into that mix for that new long life pavement. So I think we have lots to learn yet when it comes to recycled products and how to meet or exceed what we could get with a virgin mix in that situation. But there's a lot of good information out there about that now.
That's great. So the last question then I have for you is, what do you see as the future for mixed design over the next 10 years, and what do you think that's going to mean for the owners and the traveling public at large?
I think mixed design over the next 10 years is going to be a double-edged sword. I think our industry and agencies together want performance tests that in the design phase as well as under production predict whether a mix is going to fail due to cracking, due to rutting, due to fatigue, due to moisture damage. As we head down that path and find tests that people can agree on that truly do relate to performance, agencies are going to look less and less and be less involved in mixed designs that our industry does. So the industry is going to have to continue to grow in their knowledge and understanding of how to put a mix to get together. There may be folks that don't think minimum VMA needs to be met, and in some cases it may not have to be. But people are going to have a better understanding of mixed designs in order to meet those performance tests down the road and understand what they change about a mix when it doesn't meet that performance test. Do I need to get a different aggregate, a different asphalt cement, a different rejuvenator, use less wrap, use more wrap. Those kind of decisions as an industry we're going to probably be making on our own in order to meet that performance test, because the agencies, I think, are going to back further and further away from saying a mixed design is good or bad and base it on performance, especially, and they should. Their focus, I believe, as an owner should be more towards the as-produced mix and what's put in place.
That's good. Anything else you want to add?
No, sir, I don't think
Excellent
so.
job, Bill. Thank you
Oh,
so much
thanks.
for agreeing to talk with us here.
Well, I'm glad I didn't study.